Today we're going to be looking at sohcahtoa. Now, sohcahtoa is all about ratios, and sometimes these are called ratios. Now, in a test in 2CD, they often ask you, like, find the ratio, and that's talking about the sohcahtoa ratio, okay? And so this is all to do with ratios. It's also to do with what sort of triangles again? Right-angled triangles, okay? So we need to be able to know that it's a right angle triangle to use sohcahtoa. And often in tests people get really flustered and they get a question and they just use sohcahtoa the whole time, and then they realise, oh, there's no, or they don't realise, there's no right angle in there. So once again, do that first, okay? So before we can use what's called sohcahtoa, we need to be able to label a right angle triangle, okay? So we know one side, we know the name of one of the sides already. What's that called? The hypotenuse. So we already know that that's the hypotenuse. Now, after that we need to look at this thing here. What's that little sort of circle there mean? It's an angle, okay? We might know that angle or we might not know that angle, and we use Greek letters like a theta to show an angle, or we could use an alpha or a beta. There's lots of different letters, okay? Usually I just use theta. That is called the reference angle. Now, the reference angle can change depending on what we're looking for. So the reference angle could be here or it could be here. It just depends on whatever information you get given. And that means the sides related to it can also change, because we need to know an opposite side and an adjacent side. Now, what do you think an opposite side means? It's opposite to the reference angle. So what side is opposite to reference angle? This one here. Now, it's not always the side on the left, okay? It's the side which is opposite the reference angle, okay? So this is O. It's opposite the reference angle. Therefore, the other side is called adjacent, A. What's adjacent mean? Next to, okay? Sam is adjacent to Max. Okay, it's next to the reference angle. You can also know the adjacent angle because it's between the reference angle and the right angle. It's always the side between the right angle and the reference angle. So A means adjacent to the reference angle. Okay? Everything is related to the reference angle. Everyone okay with that? It should be very much revision. So if we do a quick review, we draw a couple of triangles. Sorry, they're not straight. I'm going to label that one. I'm going to label this one. I'm going to label this one. I like it. Thank you. You've had a bit of a haircut too. It's good. Can I touch your hair? This is good. It's clean. All right. This one here. What side's this one? Call it out. Hypotenuse. What's this one? Adjacent. What's this one? Opposite. Okay. What is this one? So I would highly recommend you always look for hypotenuse first. If you get the hypotenuse first, the other two are really easy. If you try and find the adjacent first, then you can sometimes get mixed up between this one and this one, because they're both next to the reference angle. But if you've already picked the hypotenuse, the rest is pretty easy. So what's this one? Adjacent, and the bottom one? Okay, and this one? This one? Luke, this one? Okay, are we all good? Alright, so sohcahtoa are some ratios we use, okay? So let's just write this sohcahtoa. 3 different ratios. They're almost completely separate from each other. So means sine and an angle. The sine is attached to an angle. Equals opposite over hypotenuse. Notice the word sine. Sine. Okay? It's not sin. If you say sin after the next 2 minutes, you're going to get push-ups. Alright? People have been in my class know this year in, year out. Okay, get it out of your system. Alright, are you done? Okay. Okay, done. Alright, the next one is cosine. And you can write cos, C-O-S, but I'm just for the first one writing cosine theta 10. Go. Go. No. Alright. Equals adjacent over hypotenuse. That was not 10. It's like 2. Okay. The last one is tangent, and we can write tan, and we do actually say tan for some reason, but anyway, tangent and an angle equals, what do you reckon the fraction's going to be? And why is it opposite over adjacent and not adjacent over opposite? Because it goes O, then A, and that's the order which the fraction's in. Okay? So opposite over adjacent. Now, just having a look at sine and cosine, why do you think they're always going to end up being proper fractions, which means there's going to be a small number on the top and a bigger number on the bottom? Why do you think sine and cosine are always going to end up with proper fractions as our answer? So 1 over 4, 2 over 10, something which has a small number and then a bigger number. Yeah? Good, because the hypotenuse is always the biggest number, which means these other 2 sides are always going to be smaller. Okay? So these should always, if you ever get stuck, a sine and a cosine should always have a small number over a bigger number. Small number over a bigger number. Why do you think this one might not be the same? Yeah?
Because you're dividing 2 smaller sides with each other.
Good, because you've got the 2 small sides, you don't know which one's bigger. Like the opposite is not always bigger than the adjacent and vice versa. So this one you could end up with an improper fraction. Okay? Any questions about that? Alright, so if I gave you a triangle, and I just said like it's a 3, 4, 5 triangle. Okay? Is this a real triangle? Are they real sides which would work? Yes, why? Because it's 3, 4, 5, it's a Pythagorean triad. Okay? Whole numbers which work with Pythagoras. Okay? So, determine the ratio sine C. This is the sort of question you get in a test and people suddenly get really confused. I know I just wrote S-I-N, but we still say sine, okay? Sine C. Okay, sine C. What would the ratio sine C be? So again? Why is it 3 over 5? C is the angle we're going to look at. C becomes The reference angle. So what's opposite to C, Nelson? 3. And what's the hypotenuse? 5. And so that's what the ratio is. What if I said tan A? So what's the reference angle we're going to look at this time? We're going to look at A. So what's opposite to A? 4. And what's adjacent to A? 3. And that's what that ratio is. Can everyone answer that? Everyone get that? All right. That's often in a non-calculator section for trig, because there's not heaps we can put in a non-calculator section. That we can. All right? Okay. Finding a side. Using sohcahtoa. Okay, I'm just going to put some steps and then we'll do some examples. Steps. Step 1, label. Step 2, pick the right ratio. So you need to pick the right ratio given the information you have. Sub in the info into that ratio and solve. Okay, so there are steps. Alright, can we do a quick example? So, for all these questions we'll just write determine the value of x. And we'll use a triangle. You are allowed your calculator for this. In fact, you'll need it, okay? So, it has a right angle. Alright, so this is the information we've been given. Okay? And what information you're given will determine what ratio you need to use. So, first thing we do is we label the information we have. So what's 8 get labelled as? Hypotenuse. What's the x get labelled as? Adjacent. And so in sohcahtoa, which one has A and H in it? Ka, okay, so we're going to use cosine rule, or the cosine ratio, sorry. So our cosine ratio is cosine angle equals A over H. We've picked our ratio. So we labelled, we picked our ratio, we now sub in cosine 25 equals x over 8. Now we need to know our algebra skills. We want to get x by itself. What do we do with the 8? Good, we move it to the other side and times it. So if the pronumeral's on the top, we always move this 8 to the other side and times it. Okay? So if the pronumeral's on the top, then we move the 8, or whatever number's on the bottom, times it on the other side. And that's just using our algebra skills. Okay? And so our answer is 7.93, what? Centimetres. No? 7.2. Oh, so you can't close on radians. 2.5. Good to know now rather than a test. Can you guys all check on your, if you've got one of these little Casio ones, up the top, there's a little highlighted, so if you've got an R, you're in the wrong system, so you need to change it to decimal. To do that, you go, oh, sorry. You go shift mode 3. Shift mode 3 on your little scientific one. On your class pad, check down the bottom that it says degrees, and if it doesn't say degrees, you need to just click on that word until it changes. So it's the bottom right next to the battery. Okay? Alright, so 7.25 centimetres. Everyone okay with this? Make sense? Okay. In like a different year group class, I'd spend a lot more time on this, but it should be revision. I'm hoping everyone understands. Yeah. Alright, let's try a different one. You guys right? You should go decimal, but standard's fine. Just depends on how you want your answer. Alright, this is the next one. It's not a trick. It's just a question you have to answer. Oh, it is a trick. Thank you. It was totally meant to be a trick. It's not a mistake or anything. Thank you for picking that up. Sorry? I'm pretty sure that was blatant push-ups. Let's go. Come on. Go. Go. No.
No, you don't.
Why is your head coloured in?
Oh, they coloured it in design. Wasn't me.
Yeah, but you let them.
If it was Josh.
There's no way you just went, oh no, I didn't want that to happen.
Josh held me down and threw Avatar on my head. I didn't do that. He did. No, it was scaffold design.
Alright, thank you. Shh. That was pretty good. Alright. Okay, first thing, what do? Nelson, what's the first thing we do? Even before that, what do we do to work out that it's sine? We label it, okay? So 12 becomes? 12 is what side? Opposite? X is what side? Hypotenuse. Thank you. Alright, so we then know that it is sine. So we write out our rule. We then do what? Sub in. So we got sine, what angle? 40 equals 12 over x. Okay, we also sub in the letter or the pronumeral for that h, because it's not asking you for what h equals, it's asking you for what x equals. And so your answer has to say x equals something at the end or you won't get the marks. Okay, so we sub in everything. Alright, this time the pronumeral is on the bottom. If I just show you using full algebra, to move this x away from the 12, we have to move it to this side. And so we end up with, don't write this down, just write it in blue, sine 40 times x equals 12. Now x still isn't by itself, is it? So what do I have to move away from the x? The sine 40. Okay, and so this gets moved to the other side. It was timesing on this side, so what's it on the other side? Not negative. Divide. Okay, it's not plus, it's times. So divide. So we end up with, and this line you do want to write down in red, x equals 12 over sine 40. Okay? 18.67 centimetres. Okay, so the rules are, thank you, Luke. If pronumerals are at the top, top of the fraction, what's that called? The numerator. Okay, if the pronumeral is at the top of the fraction, then we move the denominator to the other side and multiply. Okay, if the pronumeral is the denominator, so on the bottom, of the fraction, we switch it with our ratio and angle. See how we just switch the two around? So we switch it with the trig ratio and angle. Any questions about that? All good? Okay, we've got one last bit. Finding the angle. Okay, so those were all for finding the side. This time it's finding the angle. Okay. To find the angle, we use inverse. Inverse. So for example, inverse sine, sine -1. Sine to the power -1. Cosine -1, tangent -1. Okay? It's the only time we use these inverse signs. Okay? Now, where do we find them in our calculator? Good. If you're using your little calculator, you use shift and then you use the normal ones. If you're using your class pad, in your keyboard and under trig, it has them next to each other. So you can see them here. Okay? Alright, we still follow the same rule steps. So we still follow the same steps. So label, pick a ratio, sub in, and solve. But, okay, so it's the same ones we did before. But in our solving, we move the ratio to the other side and make it inverse with the fraction in the brackets. I'll explain what that means in a second. So we still do all the same things. Finding the angle doesn't mean we change anything except our little solving bit. So, for example, I don't know what the angle is, but I know that this is 5 And this is 4. Actually, we'll do the other side. And this is 4. So what does 5 become labelled as? H. What does 4 become labelled as? A. So we're going to use cosine rule. We then put our numbers in. Cosine theta, we still don't know the angle, equals 4 over 5. Now, the whole rule of algebra is we always want to get the pronumeral by itself. At the moment, it has cosine next to it. Yeah? So we need to get rid of the cosine, and to do that, we bring it over to the other side. Now, because there's already a fraction there, we can't put it as a divide by, this divided by cosine, which is why we use the inverse cosine. So we end up with our angle cosine -1. That's how we moved it to the other side. And then in brackets, we leave the fraction exactly the same. Sorry, I just did that in red. So to move the cosine to the other side, it becomes inverse. And we just put it next to the bracket, next to the fraction. Josh, did you have an answer?
Yeah.
And it's always going to be degrees. Are there any questions? I always answer 2 decimal places. Okay, so that's it for right angle triangles. SOHCAHTOA, area of a triangle, Pythagoras. They're the 3 things we need to know for right angle triangles. Okay?